So in this lecture, we're going to look at manufactured timber products. Now, the development and introduction of wood products has introduced a great change in woodworking techniques and also in the variety of work that can be achieved. Now, it's interesting to consider that traditional conversion methods, so that is like when we cut the tree down as we've been looking at in previous lectures, it really only utilises 40% of the tree when we're recovering solid wood from it. And what we're talking about there is we're talking about the tree as a whole, including leaves, branches, all that sort of thing. However, that very same tree, when used for composite products, manufactured timber products, uses 80 to 90% of the tree. Plywood is the most common of these composite products, along with particle board, hardboard, and medium density fiberboard. The manufacture and use of these and other products is what we're going to cover in this lecture. So we'll start with plywood. And plywood is probably the original of the manufactured timber products. It's been in development for about 100 years, but it really reached maturity around about World War II, particularly when we sort of perfected the kinds of glues that we use, the formaldehydes and resins. So the manufacture of plywood involves gluing 3 or more thin sheets of wood or veneer plies together, which is where its name comes from, with the grain at right angles in adjacent layers. Plywood typically has an odd number of layers, and that varies from 3 through to 21. In some special cases, such as bending plies, an even number is used. And you can see even from that image on the side there that you've got numbers of layers in that plywood shown there. The dark lines between each layer there, that's the glue. To impart strength and stability, prevent splitting, and ensure that the 2 outer plies are running in the same direction, so that it appears like solid wood does, the odd numbered layers are generally laid with the grain along the length of the sheet, while the even numbered layers have the grain running across the sheet. The cross-banding plies may also differ in thickness from the others, and the desired thickness of the finished sheet determines the thickness of the plies. And if you go down to your local hardware and have a look, you'll see what I mean. You'll generally see that the inner plies are thicker than the outer ones. Since its introduction just over a century ago, plywood has greatly improved in quality and appearance and is now highly regarded as a construction and also as a facing material. Where moisture is a concern or in a marine environment, waterproof plywood bonded with phenolic glues is essential and is commonly known as marine ply. Plywood is also well suited to exterior construction and concrete formwork, and you'll see it a lot on building sites. Pre-finished sheets for panelling are available, and plywood faced or reinforced with aluminium is used for insulating purposes. These are known as composite board, and you can see images of all of these on this slide. Another form of plywood is known as core board or block board, which has a solid timber core and is mainly used in furniture or door construction. A major benefit of core board is its stability and lack of twist or warp. And we touched on the reasons why timber might twist or warp in a previous lecture. Now, the advantages of plywood. Its strength and uniformity. So solid wood is 20 times stronger along the grain than across the grain. Plywood, which is over 10 millimetres thick, is almost equal in strength in both directions. Once you get a bit thinner, then obviously the plywood is not as strong, but from about 10 millimeters up, it's at least as strong as timber. Stability. So there's virtually no shrinkage or movement because plywood's alternate grain direction in adjacent layers restricts wood movement. And if you go back to what we were talking about in previous lectures, remember the difference between tangential shrinkage to radial shrinkage to longitudinal shrinkage, and you'll start to understand why plywood, even though it is still made from solid timber, doesn't move like timber does. Large sizes are available. The size of the sheet is not restricted by the size of the tree, but by the size of the manufacturing press. For example, 2.4 by 1.2 metres is a typical size, with choices of thickness from 3 through to 25 millimetres thick. It uses expensive timbers way more economically, so cheaper timbers can be used for the core so that exotic veneers, and there's a whole range of veneers that you can get, from cedars through to maples to all sorts of things, but you can leave those and save them for the face. Matching panels can be easily obtained, and plywood can be formed or bent for curved surfaces. It has fewer splitting problems, so that nailing and screwing near edges and ends is possible. And you can see there just an outline of how plywood is made. Disadvantages of plywood. So the first thing is that the exposed edges need sealing or covering, because obviously there's end grain on every edge. Due to the thin outside ply and cross banding, plywood is not as easy to work by hand. And one of the big issues that people can face with plywood is planing it, because obviously, again, you're dealing with end grain, but also sanding it. You don't want to sand it too heavily, because you can easily sand all the way through the high quality outer ply. Edges are difficult to work as all edges contain end grain and are prone to splintering. So really, if you're planing the edges, you have to treat every edge as if you're planing end grain. Working techniques. When sawing, thin sheets require support and use a fine-tooth saw. Planing of faces is difficult. Sanding with the grain is preferable, but as an aside, very light sanding. When planing edges, use the same techniques when planing end grain to avoid chipping. Marine grade ply should always be used in external applications. The second manufacture board that we're going to look at is particle board. Now in Australia, particle board is more commonly known as chipboard, and it's just important to note that we should use particle board as the term rather than chipboard. It can also be called pine board, panel board, well board, and flake board. Particle board is generally sourced from pine forest thinnings and trimmings. The thinnings are debarked and then chemically treated to prevent mould growth. They're then cut and milled into coarse and fine flakes. The flakes are then dried and sprayed with urea formaldehyde glue. Once that's happened, they're then rolled out into a mattress, and coarse flakes are sandwiched between outer layers of fine ones. And you can generally see that when you look at the edge of particle board. The mattress is then pressed between heated platens to produce strong, grainless sheets. The sheets are then sanded to an accurate, even thickness and cut to size. And sheets are available in sizes up to 4.8 metres by 1.8 metres, and a thickness from 4 through to about 33 millimeters thick. The advantages of particle board. You'll find a lot of the advantages and disadvantages are fairly similar. So particle board, accurate thickness sheets are available in large sizes. It's considerably more stable than solid wood. It's subject to almost no expansion and contraction and does not distort. It forms an excellent base for covering with veneer or laminates because of its stability. So for example, when we talk about melamine, melamine is basically just particle board with a very thin paper plastic coating over it. It's got uniform strength due to lack of grain direction. It's easily worked with hand or machine tools and with some caveats there. So for example, yes, it is easily worked, but for example, if I was using a plane on it, it would tend to chip out a bit. It's suitable for simplified carcass construction without framing. It readily accepts paint and other finishes. It's generally cheaper than plywood or fibre boards of comparable size and thickness. It's probably one of the cheapest manufactured board materials available. There are some disadvantages. Because of the porous structure, the edges require special treatment. You've got to cover the edges, particularly where moisture is involved. Particle board tends to break away on corners, and so additional care is needed, as well as specific techniques when screwing or nailing near edges. It is highly absorbent and will swell and lose strength rapidly when wet. When cutting, finishing, or sanding, the dust created can be an irritant, and that's got a lot to do with the resins and glues, that urea formaldehyde that's used in it. It also tends to blunt blades and other cutting edges quickly. Now you can see in this image that here are some common edge treatments. So like I said before, the edges do require special treatment, and they can vary from simply gluing on a strip of timber edging. For a bit of extra strength, you can have a tongue and groove timber joint with the same sort of timber edge. You can have a timber strip with a veneer overlay. So there is, I won't go through them all, you can have a look at that. But there is a range there of what you can do. Working techniques. Cutting and edge tools must be kept sharp and will blunt easily. When you're cutting to size, ensure the sheet is supported because it is liable to break towards the end of the cut. And also use a specialist, so you can get specialist particle board blades or a fine tooth blade. And you can see down below there, if you're making carcasses out of particle board, here are some different joining techniques. So particle board can be glued edge to edge to increase width using butt joints, housing, and rebated joints. Apply at least 2 coats of adhesive because of high absorption. So it does actually, absorb a lot of glue. When using screws, bore the necessary shank and core holes for the full length of the screw, as it otherwise splits easily. Or preferably, use specialist particle board screws with a full length thread. Do not over tighten screws as they will tear the fibres, and use lower torque settings on powered drivers. And that's where the main problem comes, is on powered drivers, driving the screw in and then over tightening it. And sheets that have veneers on them should be stored with veneered face down. So what's it used for? Well, it's used as a base or inner core for veneers and plastic laminates. In the furniture industry, extensively for carcasses, tops, drawer parts and shelves. And many of you will know, because it's in your own homes, it's used in kitchen carcasses and built-in wardrobes. Shop fittings, shelving, partitions, feature walls and flooring. So you can see that it's used quite extensively. Now there's three main types of particle board. All have similar methods of manufacturing. What they have difference is different resin types that modify their properties to meet specific applications and the environments in which they're used. I'll have to fix up those typos there. Interior particle board is manufactured using urea formaldehyde as a bonding resin. It must not have contact with water, used as a basic cabinet board. So that's the most common one, really. It's often laminated with veneer or plastic laminate, which we call melamine, for cabinets, furniture, interior partitions and feature walls. Flooring. So you do see this a lot these days. So one of the largest uses in recent years is flooring. It's highly moisture resistant. A phenol or tannin formaldehyde, so a slightly different kind of formaldehyde, is used in the surface layers, and urea formaldehyde is used as a bonding resin through the middle. It's commercially known as yellow tongue. High moisture resistant, HMR, uses a urea formaldehyde resin plus a blue dye in the core resin to distinguish it from other types of particle board. Wax emulsion is included in the resin to repel water. This board is used extensively in kitchens, again as the core for plastic laminated coated boards, and as structural wall bracing in timber framed houses. The third one that we're going to look at is medium density fiberboard. Now there is another form of fiberboard called high density fiberboard, HDF. I don't go into it deeply here, and the main reason being is the main difference between MDF and HDF is the source material. So for example, medium density fiberboard is made generally from radiata pine, from forest thinnings, whereas HDF, high density, is made from hardwoods. We also know HDF as masonite. So medium density fiberboard is manufactured in Australia under a variety of trade names such as Craftwood and Fibron. The raw material is radiata pine, which is obtained from thinnings and residual material. So that would be material left over. Say if they were going into the forest and taking out logs for saw logs, they can still use some of the smaller branches to make MDF. And when we talk about thinnings, when we're looking after our forests, particularly our plantation forests, generally after a few years of growth, the foresters go through and they thin out the forest and they take out the smaller trees, leaving the bigger, healthier trees. And so what gets taken out, they're called thinnings. In the past, the thinnings were literally just either left on the ground and burnt, whereas now they can be used for manufactured board products. So the thinnings are debarked and chipped to a specific size. They're then washed and conveyed to digester units, which soften the chips in a cooking process. So the heated chips now enter single disc defibrators, which rub the wood apart into fibres. The fibre is dried, and at the same time, the urea formaldehyde resin and wax is added. The fibres are then stored in a dry fibre bin prior to entering the forming machine. So this machine forms the fibres into a mat. It kind of spreads it out evenly, which it lays onto a conveyor to form a mesh belt. The fibre mattress is then passed through a pre-compressor, which reduces the mattress height from 300 millimetres down to 100 millimetres thick. It then goes into the hot press, where the combination of heat and pressure cures the resin and produces a sheet of MDF. And you can see that illustrated there in that image. So the advantages, and again, very, very similar to the other manufactured boards. So it's available in large sheets up to 3660 millimeters by 2440 millimeters, so quite sizable, in a range of thicknesses from 5 all the way through to 32 millimeters. Compared with solid wood, it's subject to little expansion and contraction. It retains its shape well. It forms an excellent base for covering with veneers or laminates because of its stability. It's got no grain direction, therefore it has uniform strength. Easily worked with hand or machine tools. Again, we just need to put a caveat on that. Can chip out a little bit and it does blunt tools pretty quickly. It requires no framing for carcass construction and finishes bond successfully and evenly. It cuts easily, it routs, and it sands easily. There are some disadvantages. So it gives off fine sawdust when machining, which can be an irritant. Similar to particle board, it is liable to break away when nailing or screwing near edges. So the working techniques are similar to those for particle board, although in the case of MDF, no edge treatment is needed. This means that edge treatments such as routed profiles can be done directly onto the surface with a durable paint finish sprayed over the top for excellent results. For example, if you tried to do that on particle board, you wouldn't get a nice clean profile because the chips would just break away. Same with plywood to an extent, where again it might chip away. The uses as a base for core veneers, similar to particle board in that regard, plastic laminates or painted surfaces. MDF is used extensively in the furniture industry for carcasses, tops, drawer parts, shelves, picture frames, etc. Now we're just going to look really quickly, really only just in summary form, at other manufactured timber products. These are more specialised, however, they are being used more and more today. So there's a wide range of other products that have been developed in recent years. These will be listed here for you to research a little bit further. So we've got finger jointed timber, and there's an image there of that. And really all it is, it's just a way of maximising small offcuts by joining pieces together using finger joints to form longer boards. And the reality is this timber, it is cheaper, it uses a material that would otherwise go to waste, and because of the strength of modern glues, it's at least as strong as solid timber. Laminated veneer lumber, LVL, is an engineered wood that is similar to plywood but has no cross banding. So each layer has the grain running in the same direction. Glue laminated timber, Glulam, is made by laminating thick pieces of seasoned dressed timber in order to make larger structural members. And you can see an image of it there. So it kind of is the same concept as finger jointed timber, just going the other way. Instead of increasing the length, it increases the thickness. Oriented strand board is another. So it's a type of engineered wood similar to particle board, made by gluing layers of wood strands in specific orientations under pressure. And more information about these products can be found at this website, which is Wood Solutions, which is an Australian website that provides, it's a very good source of information about timbers from the Australian context. Now, finally, there's probably some issues that we need to consider. So large trees being used as solid timber are becoming rarer and more expensive. It seems the engineered wood-based projects will increase in usage for a range of reasons. Large diameter logs are in severe decline, whereas there is an oversupply of smaller diameter timber logs, and that's because of forestry and forest thinning. The quality of plantation-grown timber is often unacceptable for structural purposes. So it's just not strong enough, or it contains too many defects. Engineered composite timber is strong and can compete with steel and aluminium. Consider also that these materials face challenges when it comes to recycling or disposal. And we're going to look more closely at these issues in next week's topics.